So, you might have guessed I'm going to talk about JavaScript. And what I'm going to do is first show you my problem, what I have with JavaScript. Is that most of the applications that I encounter in the wild are just globs, global globs. And what I mean with global globs are like, they are very big. They all are attached to like one global object, and they use like one major file. You know the worst case here. So they're just one file or multiple files, but they also always attach to one global. They always use the same data. They always reuse, they attach, they touch everything in the application. So recognize this pattern, the global blob? No? Okay, strange. So, okay, but the problem is, this is not an architecture. This is a problem. The problem is that every new feature takes more time. Testing has become impossible to do. So, what's next? Well, I'm going to give you a 3-step program how to solve this problem. Step 1. It's an easy one. Study the language. And now I'm going to be a little bit going to rant about it. And it's a little bit of my thing. But most of you guys who can I get a hand on the JavaScript developers? And also if you write JavaScript, say once a month or so. Okay. How many of you, keep the hands up, keep the hands up. How many of you read the good parts? Okay. How many of you read another book but the good parts, something like functional programming, security on JavaScript, had informal education, or anything hard? Okay, that's less hands. And there lies a major problem. Most of you guys don't know what JavaScript is about, and you just start writing code. Some of you come from Java, some of you come from PHP, and you have no idea what you're doing. You're just writing, just writing code. And the problem is that JavaScript is a weird language, and it has a lot of quirks. And if you aren't careful with those quirks, it can really screw up your application. So remember, step 1, study it. So I'll get your notes. So I'm gonna download a new ebook about it, and maybe something on scalable architecture. Okay. Step 2, be critical of frameworks. So, who writes vanilla JS? It's just applications, just vanilla, some. And who writes all their JavaScript in frameworks? Oh, come on, Angular, React. Who can really debug those applications? Who have read the source codes? Oh, one guy. Oh. Okay, this is rant number 2. We'll get to the next part, but problem is when you're building like big application, you want it to scale, and the first reaction is, okay, I have a big team, I have a big problem, I want to go to a framework, and framework will help me scale. Well, frameworks don't help you scale. Frameworks are like very niche, over-engineered products for very niche teams, and that doesn't make scalability. For example, what makes even this slide, most problem here is, if you're using a framework, your Facebook, you have React, you have Redux, you have Google, you have Angular. Funny thing is that they don't use Angular really a lot in production, but you have your big-ass frameworks, and those work for them. But that might not work for you, and in the end, you're not scaling. You're just screwing yourself over, because you are developing by coincidence, what means that you have no idea what's under the hood. And if anything goes wrong, you will have a bad time. Okay, step 1, step 2, and now the rest of the talk. Step 3, how do you scale? How do you scale? Well, scaling is a lot about optimizing and making all a little bit simpler. Like you saw in the previous presentation by Harry. Harry explained it a lot, that if you just simplify it, it will become, you can do more complex stuff. So a lot of the stuff as he was talking about, immutables, I forgot about the presentation. Okay, well, like immutables, that's something you can reuse. Okay, just keep it all in mind. So, think about it. Design patterns, what are design patterns in essence? Well, they're like little pieces, well, not little pieces, they're like pieces of code who are highly optimized, and they solve like any day programming problems. So very smart people have been working on these for like 30 or 40 years. They solve those problems. You don't have to think, they do it for you. One of the major books, which you look here, is the Design Patterns, which is just a catalog of all these little templates. Funny part about those templates is they are never language dependent. So if you have a good design pattern, you can practically just rewrite them in each language, which makes them fun. But they're not silver bullets. So first big remark, and I'm going to repeat this also at the end, is that using the wrong template, using a template in the wrong situation will be a pool of tears. Using it in the right situation will be a joy or a savior. And that is, again, that's a back remark on what frameworks do, is they are very opinionated implementation of these design patterns, and they might work for the big corps, their implementation, but most of the times they're just the wrong patterns for your problems. So you're making everything way too complex. By the way, if you have questions in between, because it's going to be technical, just shoot. So, roughly, you have I think 4. The one is, you have 4 major patterns. You have structural, which is how do I structure my code. You have creational, how do I, it's like hence the name says, it's more about creating objects. Then you also have behavioral, which is how do you communicate in between pieces of code. You also have a fourth one, which is more of concurrency. So if you have multi-threads, but yeah, we're using the web, so we don't have this problem. So today I'm going to exemplify, I think, from each category one. So now the interesting part, so that all the rest was just talk. Now I'm going to I show you my favorite 5 patterns. These 5 patterns I just use in every application I build. I do it in vanilla. I even reuse them when I'm doing some game dev in Unity. They're just the backbone of any application that must scale. Of course, this is an opinion of me. There are different design patterns out there. I think there are around 50 or 60, but that's too much to get all in one presentation, so I give you 5. Okay, first one. Oops. First one, this you might recognize. This is the revealing module pattern. Roughly, this is just it's more like when you come from another language, what is a module? A module is more something like a class, something very focused, a very focused, how do we say? It's like class, except for the inheritance, only just one small piece of feature or code that does one thing. It can be anything. It can be a button, it can be a timer, it can be like an audio element, or just one piece. What is the difference between a normal module and a revealing module? Well, I'll show you in the next slide, but the major difference is with a normal module, you would be like using this or whatever variable that your module is, and would be extending it with new variables, and you would be almost, by itself, expose everything. While a revealing module everything is declared in the function, so everything is private by standard from initialization. So, and then at the end, you return a object literal, which is where you declare very neatly declare everything you want to expose. I know this is very, high level, but I can show the example. So what I mean, this is for an example of a module I've written in pure JavaScript vanilla. It's nothing more than just a function with parameters. And if you look, I have two functions with our privates. If I would declare like any variable in here, it would be private. And then at the end, I just return an object literal, which is like, well, whatever, it's just an object. And there I declared how the methods are returned. So I can even change name. Fun part about this is that I'm not exposing any of the internals. And I also make very clear what the intent was of the module and what the intent of the developer was. What brings us back to the previous slide. This makes very highly testable code. Because you have very contained pieces of code, you can just unit test them any way you want. You can just like, if you go back to param, if you just have the module function parameter, that's like dependency injection. You only need to do is just inject the param, and if you want to test it, the only thing you need to replace is the parameters. And then you have the everything the module does, you have it under perfect control. Okay, in a structure, how would this look? Roughly, if you have like, my example is like a stupid HTML5 audio player. Normally, say the old way was to build one file and extend everything to the one object. Well, now I would be just splitting it all up in smaller pieces. One thing important is, it's like a saying, if you want to solve a hard problem, you just need to split it up in smaller solvable problems. This is what it does. It just splits it up in smaller problems, and if the problem even then is too big, you split it up again. So it's the main, well, that's the index, that's what always happens. Yeah, it's a program, so you need somewhere to start. Roughly, I would just require the audio. What is the audio? That's just a stupid module that creates an audio element, maybe gets in a param for the URL where the MP3 lives. Does nothing more. Require is the import of CommonJS. Nothing fancy, but what also I need is like controls. So just require controls. Then I have two buttons. Simply as that. I need two buttons. I create two submodules. I have one play button, one progress button. This is simple. Any questions? No? Okay. What does this give you? No, more important. Okay, so super important. This is a little bit of my own experience I have. But okay, now you have your big blob, you split it up in all smaller parts of code, and it's neatly structured. But there's some things you shouldn't do, and I see it too much in the wild on GitHub, is first access globals. There is no point in structuring your code in smaller parts if you still have guilty knowledge of other parts of the application. So what does it mean? I see too much. Okay, sometimes you cannot do something else because there's a third-party library that only works on globals, but you don't want to use globals. It makes them untestable because that's a factor you don't have under control when you're unit testing. The other one is it extends the globals. This is the same thing. I've seen this like big libraries that just have split it up in nice little modules, and in the end, they don't export the module. Well, what they do is just they check if one global is there, and then at the end of the module, they just extend it, attach it to that one global. Again, this makes using modules just stupid. That has no reason for doing that. What else? If you want to be a good boy, don't alter the inputs of your params. This is more of the, like I said, the immutable way of thinking. I don't know if it's React way, but if you get like data into your module, please don't alter the original data. Just leave it there and make your own copy. This is more of a functional way of thinking. Just make your own subset, copy it, do whatever which you want, except if it's really do what you want, and then return something new, but don't touch the old data. Again, you need to have focus in a module. Then, of course, super long modules. I've seen this all too much in projects and on GitHub is people just writing modules of 2,000 lines. That's not maintainable. That's not a module. That's That's like a mini global that you're doing there. So what I do is I keep my modules, well, this is an arbitrary thingy, but I like to say maximum 300. I know it's not feasible all the time, but just keep them small and focused on the modules, on what they do. They need to have a like single purpose. If you're doing more than just including, just more than the intent of the module, you might need to split it up in more sub-modules. And of course, this is the most fun part, is think that this is easy. This is not easy. This is hard. This is programming. This is, you need to, this takes really time to get hang of it, because splitting up, it's easy just drill down the whole page and rethink every part of your application as small modules. It takes work, it takes time. I'm not really good at it, but I get better with the module. So everybody can do it. Okay. Next, but most important part is if you start using modules in JavaScript, you can like totally embrace the ecosystem of JavaScript, because we mainly from Frontend United and Frontend, we use JavaScript from more jQuery or a library perspective. But if you look at JavaScript from a Node.js perspective, it's a total different thing. And they really embraced NPM and the modules and how the modules work. What the fun part is about it, that you can reuse little pieces of modules from all over the internet. So, quick introduction on the module systems in JavaScript. Well, you got CommonJS. CommonJS is Node way of doing, which is synchronous module definition. Then you have AMD, which is asynchronous module definition. And then also you have the new ES6 modules, who are something in between. I thought they took the syntax of Common and the asynchronous of AMD. Only problem is, for now, except for ES6 modules, is that the browser doesn't accept them. If you write like modular style in Node, Node will compile it, he knows what to do with it, browsers don't. So you still need something like a module loader. And that's why we've got like browserify. There's nothing more that's for CommonJS. You have require for AMD. And you also have Webpack Webpack. Fun part about Webpack is that it's pretty much universal. It doesn't care. So you can throw Common at it, can AMD or ES6, and it will fix it for you. So that's why I'm using Webpack now. But, most important, NPM. I love NPM. It has so much, anything I could think of, there's a module for that. I can just write code, I need to check for an outside click out of my div. Instead of doing that with a super big whatever, I just Google NPM and say outside click. Okay, I find the thing and I do NPM install save, and then I just go to the module I need it and I require it. Same goes for like Lodash or whatever the thing you need. So what would that mean if we would extend our files? Well, we have still the same thing, controller, audio, play button, progress, but in the play button, I want to go fancy, and I wanted to use some virtual DOM and some Lodash for each. So the only thing I have to do in my module is just require it. That's it. Browserify, Webpack, whatever, will get all the dependencies for me. I will bundle that nicely into one executable. Okay, next problem. So you have modularized your whole application, all little snippets. The only problem is that when you had the big global that could touch everything, you had all the data available. But now you have little modules who all do their own thing, but the problem is they all have dependencies on each other's. And that starts to become a problem at some point. Well, let's say, for example, you have the audio, the progress bar, and the play button. They all have circular dependencies on each other. So when I press the play, I say to the audio module, okay, play. When the play audio stops, at the end of the file, it just sends back, says to the play button, stop. Same for the progress, they update each other. Okay, next week, the client wants video. Okay, well, you have to trust me, it's a video. Next week, the client wants a video. So what do you want? So what you do? Well, you create a video element. You add some dependencies again. Hoppa, that's 2 more dependencies to take count of. Next week you say, oh yeah, but I want to add some play rate editing. Okay, you add a play rate. Only problem is now the play rate needs to take care of the audio and the video. And it needs to know which one is active at that moment. And even then it goes fancy. It says, yeah, we need YouTube. And you start to see like a problem here. There becomes a lot of dependencies, and this is a very simple application. But think about, you have like 30, 40, 50 modules, and they all start like weaving this web of dependencies. And this is mainly a problem when you're building UI components, because yeah, my buttons need to communicate to audio and to video. So what do? Well, you implement the mediator. Yeah, I've gone beyond that point. It's my favorite pattern, and I really like it because it saves a lot of time. What does the mediator pattern do? Well, the mediator pattern is like a publish and subscribe function. So it does nothing more. It just you can say to the mediator, okay, hey, hi, mediator. Okay, next. Okay, that's the play button. Sorry for the play button, the play rate, whatever, the mute button. What you do is just you have one dependency in your UI for every component, and you just say, okay, play button says if somebody starts playing. Okay, well, compressing example, do an example. Okay, simply, this is what the mediator would implement. Mediator is like public subscribe. So as a component, I can ask the mediator from, hey, if this event happens, could you please execute this callback? But on the other side, I can also do, hey, mediator, this event just happened, just send out this event with this data. What makes this? Makes a lot of fun. So this makes like my whole UI component totally decoupled of the rest of my application. For example, so I create a big button, I have a state, I have an inner HTML, and then I just declare mediator on media playing. Well, just change to pause. And then if mediator on media pause, just change to play. That's it. That will just listen on those events. Second, as last, if somebody clicks a button, the only thing I need to do is mediator.trigger, media play, media pause. That's it. Media playing is when the audio element is ready or the video element is ready. Pause is just like the action, and this is the reaction. Fun part is also, if I'm not changing the element itself on play, because, for example, it could go something wrong when the element is not ready. So I wait for the final event to happen before I state change. What does this mean in our scheme? Well, it means that there is no direct dependency between our play button and our YouTube or audio or video. So I can change anything I want. So I can just send out play events, or I can pause, and it doesn't matter. At that point, the audio element, the element that is responsible for receiving, for listening to this event, will react. So video, audio, doesn't matter anymore. This is pretty much the foundation of any UI system that's out there. Okay. Except for decoupling, what does it give us? Well, it gives us a lot. First of all, debugging just became super easy. So because if your whole application, every interaction, every communication between your modules is done by this messaging system, you can just console log every message, and then maybe you have like a fatal error somewhere. You can just let it stack up in the console until the point, and then you see, okay, it has crashed now, and you see like whatever. Okay, and my music player started, he started playing. Okay, some event he stopped, and then the whole application. So you can easily backtrace the whole application. Second, regression testing became easy. Same with some of end-to-end testing. You have a perfect map, a perfect flow of what happens in your application. You have a footprint of everything. So you can just say, okay, I know if my application loaded and I sent out this event, I know this event will come out at some point. If those two events happen, I can just say, okay, test successful. Same goes for unit testing. Because you remove most of the dependency injection, most of the dependencies of a module, you can easily unit test because you know what events are coming in and you know what events need to come out. Unit testing. And refactoring becomes up because you're cutting every dependency from the UI. So you can throw away, add elements, throw away everything you want. It will still work. Not everything, but most of the application, it will still work because in the end, you have created some protocol inside your application, which facilitates refactoring. Okay, and of course, measuring. So this is not important for developers, but most of the marketing, they like their Google Analytics. So instead of having to inject Google Analytics in every little component of your application, you can just, again, watch the whole flow of events and then react to those events and send out a Google Analytic. For example, I want every time the user clicks play, I want to send out a Google Analytics event. Well, I have the event, I just need to rewire it to Google Analytics. Simple as that. Questions? Okay. Okay. Think about it. Global blob, you have your modules, you have your inter-module communication. Okay, but you don't have everything at that moment. Then you still don't have a good architecture. You still need to have some way to store your data and somewhere to create objects, somewhere also to put your controllers. So just create whatever global doesn't fit anymore. So first we use a singleton. Who knows a singleton? Ah, that's easy. I don't have to explain this one. Well, singleton is a very easy way to create single instances for your whole application. So it's nothing more than just look like a module constructor. Does nothing more than that. And the thing is, it gets only instantiated. Yeah, it can only. Anyway, there's a factory. Oops. This is a singleton. Because there's a big difference between those. A singleton is like you have one instance for your whole application. So the moment you include it in your application, it gets instanced once. And every time you reuse that module, require it, you will get the same back. And this is how CommonJS mainly works. So important point, if you would be working with browserify and CommonJS, and you would be requiring two modules in different places, it will always instantiate the module only once. So it will always return the same module. It's important to know because it can create some bugs. If you have multiple instances of an application, you might be reusing the same modules, and that can really fuck over your application. Okay, singleton. What is not the opposite, but it's morely the same thing, but better, not better, different, is the factory. What does the factory do? Well, the factory is it creates objects. So where the singleton creates one instance, the factory gives back mainly a constructor function and allows you to create new instances. This is very handy if you're creating UI components, so buttons, whatever. The button I gave you a little bit back, that's a very good example of a factory. But watch out. So you are creating your little data services, putting your user objects or your user data in little services who can get back the data. But you need to watch out because it's JavaScript. And the fun part is, so you've written a little service. At the initialization, you pass it the user object and you're never going to change it. And then at some point, you are altering you use a service, say, get me the user data. And at some point, you're altering the little bit of data you got back from this service. And then you notice that the data's changed for the whole application. And that's because pause by reference. This is a big one. In JavaScript, if you pass around objects, it will not give you it will not pass by value. So it will pass you a reference to the object. So you will be always working with the same object. So if you create a service with users, with all your users in there, if you like do get, it will give you back the original, a link to the original data. This is super dangerous. But you can solve this. There are many ways to solve it. You can alter the getter and setters. You can freeze it, or like Harry said, you can make it immutable, which means that the data set is not editable anymore. Or which again is a big remark. You know the library Immutable JS, most of you. Watch out for performance, because it really works very well on larger sets, but if you start using it on smaller sets, you will lose a lot of you will have a lot of performance issues there. So my 2 cents is here. I use Immutable for very large data sets, or whatever. You have also icepick, which is smaller footprint, and for really small data, little like 4 or 5 attributes, I just clone the hell out of it. So you just have low-dash clone, or even if you can do a dirty trick, is JSON parse, JSON stringify, and then just clone it back. So you will be sure that the data that is sent back from the service is never editable from somewhere else in the application. Why is this important? You have no idea how the application is going to grow. What our people are going to do with the data? Okay. This is the last pattern. I'm really rushing through this, but hey, no problem. The facade. So we cut all links to the global object. So we created modules. We created little services that help us. But now the problem, now we got to open up to the world. So we need to show give the users the power to like use our module, our big app. The facade will help us with. So we don't edit the global directly. So what we do is we add a little module, which is the facade, which is super simple. It's a stupid module, and there we like inject our important stuff like the user, the mediator, and then there we create a small, as a constructor function, we create a small object that gets exposed to the other world. So service, so get user. Important about this is, again, this is security, so we're never really exposing our internals to our internal APIs. So if uglification happens on this, the whatever service mediator trigger service, all the functions who are called in the end will just be uglified, but the external API will never be uglified, so nobody will ever know what you're doing, security. Also, you're hiding the inner workings of your feature or application, which is, again, good if you're working like in multiple features, so you can wrap, have 1, 2 or 3 big features with modules, and then you can just wrap a facade around that, then around every feature, and then have a very beautiful way of communicating them without really knowing what the module does or the feature or whatever does. Okay. So that was my big rush of design patterns on a Friday morning. Okay, so closure. First, please study the language. It's a big one. Be critical of frameworks. Again, modularize, use Mediator to cut dependencies. Again, with modularize, if you're working now in a very big application, I would advise you that don't rewrite it from start. Just start with smaller parts, so one little part for your application, and then just put it in a module, and then so part by part, don't just refactor the hell out of it. Also, use creational patterns like singleton, factory. Also, important hide inner workings, and most important is use the right pattern and use it in the right place. Okay. Questions? Shoot.
If you have a global dependency like Mediator or whatever, you need that in the module. How would you do that?
There are 2 ways. You can shim it. And shim it, that means that you kind of tell the module loader. Yeah, well, some of the modules have a module way of doing it, or some fork that does it the module way, or you can shim it, and that means that you just say practically to to the compiler about the browserify or the webpack that, okay, I know this is global, but I want to use it locally. That's pretty much it. So you can keep just writing the regular module way. But not every library does it. Sometimes you really have to use the global. Other questions? Shoot.
You have this mediator pattern. Is that any different from the sort of event aggregator that, for example, jQuery has?
I don't think so. It's a very standard event system. I know that's why I say it's as a foundation of a lot of the UI development that's done. Not only in the web, but most of you guys know this on and trigger. I think in jQuery you can also trigger your own events. Yeah. It's a long time since I used jQuery, so so that's pretty much exists. I think almost every library has its own event system. Most of the time is a little bit tucked in the way. I think even Angular has it somewhere in the root scope, or I think React, you can build your own in React. Yeah, doesn't matter. Most of the libraries have those. It's okay to use them. Other questions?
Which library do you use for
Mediator.js, which is a standalone implementation of the Backbone one. So Backbone has it. Yeah, okay. For example, Backbone events, which is I like it. That's a nice syntax. It's on trigger, all what. I think if you npm search it, you will have like 10 or 20 ones. They're all little difference, but in the end they do the same. But I like the Backbone one. It solves a lot of problems. Like I like the one I like the most about it is that you can like add little context like IDs at the end. So you subscribe, and then at every subscribe you add an ID, and then when you have to like throw away a module, you just say, okay, unsubscribe everything with this ID, which is pretty handy if you have like larger modules or if you just don't want to unsubscribe every one of them, which is important also if you have a mediator and you're destroying objects. Please remove your unsubscribe from all your events, otherwise you can have really strange behavior. Okay, questions?
You had a slide where you were talking about JavaScript passing by reference by default.
On objects, so not for primitives.
Yes.
Yes.
And could you explain what you mean?
Well, so no, it's. I'm not going in details, but it's roughly if you would. Well, I'm gonna explain it by the previous. Wait. For example, this is a perfect example. This is my factory, so I create the user service. So JavaScript is passed by value for primitives. This means user.name. Primitives, I mean a string, number. I forgot the rest of them, but string and number. Most important ones, like if I do function getName, it will return me a new value. So if I would later on would be editing that value, it would never change in this factory, in this instance. But if I would do the get and return the whole user object, it would pass, well, it doesn't do pass by reference, it copies the link to the object. So, well, it's in a nutshell, it's pass by reference. So it's passing you the reference to the object. So in fact, you have, when you edit later on the object, you will be editing the object who is inside of this service. Well, service, I did Angular development for years, so I have the bad naming for that, but in this factory. Okay. Is that the answer you wanted, or?
Yeah, I was just wondering because I guess JavaScript has no pass by reference. It's indeed a copy of the reference that you...
Yeah. So yeah, it's kind of pass by reference.
Yeah, well, if you would instantiate a new object inside the function,
yes.
Then the reference of the initial is not updated. So if you would pass by reference.
Yeah. Okay. You know, it's yeah. So if you would be returning like a this user object, and then later on I have the user object, and I would just throw in that user object a new object, it wouldn't update the old object. Yeah. Google. For those who don't understand, just Google it, and there's some nice slides about it. Just keep in mind if you're passing on objects, be wary. Okay. Other questions? Okay. Thank you for your attention.